Good morning, HOD Professor A.K. Chaturvedi sir, my seminar guide Rajan Kari sir, seminar coordinator D.P. Sharma sir, faculty members, examiners and my batchmates. I am Kashish Malkani, pursuing my B.Tech from University Department of Mechanical Engineering, Rajasthan Technical University, Kota, Rajasthan. I am here to present my seminar presentation on regenerative braking system. Each time we apply brakes, momentum of vehicle is observed that it has gained by it, and re-acceleration the vehicle we have to start from the scratch to redevelop the momentum by using the more power from an engine. Thus, it will ultimately result in huge wastage of energy. As the basic law of physics says, energy can neither be created nor be destroyed. It can only be converted from one form to another. It will be good if we could store this energy somehow, which is otherwise getting wasted. Reuse it next time. We started to accelerate. That's the basic concept of regenerative brakes, which provide braking for system when needed by converting the available energy to some usable form. These are widely used in electric trains, the latest electric cars, etc. Regenerative brakes is an energy recovery mechanism which slows a vehicle by converting its kinetic energy into another form, which can be either used immediately or stored until needed. Thus, the generated electricity during the braking is fed into the supply system, whereas in battery, electric and hybrid electric vehicles, the energy is stored in battery or bank of capacitor for later use. We need a regenerative braking system as in low speed, stop and go traffic where little deceleration is required. The regenerative braking system can provide the majority of total braking forces. This vastly improves fuel economy with a vehicle at higher speed too. Regenerative braking has been shown to contribute to improve fuel economy by as much as 20%. Consider a vehicle which is operated in the main city with traffic, where traffic is major problem. Here one has to apply brakes frequently. Such a vehicle, the wastage of energy by application of brake is about 60 to 65%. By the use of regenerative braking system, we can save this energy. In regenerative braking mode, the car's engine slows down on an incline. When force is applied to the brake pedal, the vehicle slows down and the motor runs in opposite direction. When operating in opposite direction, the engine acts as generator and converts stock energy into electrical energy. In this way, fuel consumption and emission are reduced. In high-speed vehicles, braking force is lower and therefore does adversely affect the traffic flow. Vehicles driven by electric motor use motor as generator when using regenerative braking. It is operated as generator during braking and its output is supplied to an electrical load. The transfer of energy to the load provides the braking effect. Regenerative braking is used on hybrid, gas, electric, automobile to recoup some energy of electric loss during stopping. This energy is saved in a storage battery and used later to power the motor whenever the car is in electric mode. Some types of regenerative braking system are electric regenerative braking system. In electric system, which is driven only by the means of electric motor, the system consists of an electric motor which acts as both generator and motor. Initially, when the system is cruising, the power is supplied by a motor. And when there is necessity for braking depending upon driver's applied force on brake pedal, the electronic unit, the charge flowing through the motor and due to the resistance offered by the motor, rotates back and acts as generator. And the energy is stored in a battery or bank of twin-layer capacitor for later use. Hydraulic regenerative braking system. Hydraulic regenerative braking system uses electronic components as well as hydraulics to improve vehicle fuel economy. The HVR system is intended for commercial vehicle and mobile equipment. The company says that the initial measurement shows that HRV system reduced the fuel consumption in their vehicle by up to 25%. Flywheel system. In flywheel system braking system, the system collects kinetic energy of vehicle to spin a flywheel that connects the driver shaft through a transmission and gearbox. The spinning flywheel can then provide torque to drive shaft, giving vehicle power. Regenerative braking using Newton spring. While braking kinetic energy is stored in the form of potential energy in spring, when the system actually demands for acceleration, the potential energy stored is given back to the wheels to power them. Electromagnetic braking system. In electromagnetic system, the driver shaft of the vehicle is connected to electric generator, which uses magnetic field to resist the rotation of drive shaft, slowing the vehicle and generating electricity. Some applications of regenerative braking system are: it is used in kinetic energy recovery mechanism, widely used in metros. Regenerative braking systems are used in electric elevator, planes, lifting, motor. Used in electric and hybrid cars, electric railway vehicles, electric bicycles, etc. It could be used in industry that uses a converter system to move material from one workstation to another and halt at a certain distance after prescribed interval. Advantage of regenerative braking system: better performance, cut down pollution related to supply generation, efficient fuel economy. The fuel consumption is reduced dependent on machine cycle, vehicle design, automation, control plans, and individual component efficiency. Reduce wear and tear in engine, reduce brake wear, cutting down the replacement brake lining cost and cost of labor for installation and machine downtime. Reduce emission, cut down on pollution related to power generation, engine decoupling, reduce the total number of revolution and thus engine emission. Smaller accessories, reducing fuel. Some limitations of regenerative braking system are: in practice, regenerative brakes takes time to slow down a vehicle, hence most of the vehicles that use them also have friction brakes working alongside. This is the only reason why regenerative brakes don't save 100% of braking energy. High cost of components, engineering and installation. As compared to dynamic brake, regenerative brakes are needed to match the power produced by input supply and is achieved only with the help of development of power electronics. A regenerative braking system is limited when the batteries storing the recovery energy are 100% charged. The excessive charge would cause the voltage of battery to rise above a safe level. Added maintenance depending on the complexity of design. Any questions?
How can you say regenerative braking is efficient for metro?
Energy cost is about 5 to 15% operating cost in metro, and transition power consumption accounts for 60 to 80% of this energy cost. Saving achieved through the regenerative braking is average of about 20%. Hence, this is an acknowledged as significant step for energy saving. Regenerative braking has indirect benefits in terms of reduction of maintenance, increase in train availability, and reduce heat load in underground corridors.
One more question. Why is regenerative brakes assisted with the friction brakes?
Traditionally, friction brakes is used in conjunction with mechanical regenerative braking. The regenerative braking effects drop off at lower speed, therefore friction brake is still required in order to bring the vehicle to a complete halt. Physical locking of rotor is also required to prevent the vehicle from rolling down hills. Friction brake is a necessary backup in event of failure of regenerative brakes. Most road vehicles with regenerative brake only have power on some wheels, and regenerative braking power only applies to such wheels. So, in order to provide controlled braking, difficult conditions such as wet roads, friction-based braking is necessary on the other way. For these reasons, There it's a typical need to control regenerative braking match the friction and regenerative brake to produce desired total brake output. Thank you.